Hello, I'm Naomi Pfaff, and I developed and designed the magic word together with Dr. Bernadette Spieler and Professor Wolfgang Slany. Environmental influences have led to a disproportionately low number of women in STEM subjects. This is especially true for computer science. So, we created a serious game that is designed to create an interest and some fundamental knowledge of coding in teenage girls. This game was created in a Catrobat application. Catrobat applications teach users a programming language that is like Scratch but is designed for use on mobile devices. To be effective, a serious game like the magic word needs a well-designed learning mechanism and positive motivational qualities. In the following presentation, we will investigate if this is true for the magic word. The learning mechanism in the magic word is based on the idea of problem schemas. This idea is best illustrated by a study conducted on chess champions and people that were new to chess. Both groups were asked to remember real chess constellations, that is, chess constellations that can really occur in a game, and they were also shown chess constellations where the figures were placed randomly on the board. Chess champions only showed a better recall for real constellations. This suggests that there was no actual difference in memory capacity between the groups. Chess champions remembered more real constellations because they already had mental representations of categories of chess problems saved in their long-term memory. Referring to these categories enabled them to recall more constellations. So, what makes a problem category? Problems that are solved in the same way form a category. So problems are saved in one category in long-term memory if they can be solved using the same problem-solving process. Problem schemas are mental constructs that allow patterns to be recognized as belonging to previously learned categories. So, going back to our chess study, the pattern that's being recognized would be the chess constellation, and the category would be the long-term memory representation of a group of chess problems that are solved using the same problem-solving process as this chess constellation. So, a learner with a problem schema for the problem that they are solving is able to recognize the problem's category and thereby recognizes what kind of problem-solving process is likely to be successful for this problem. In this way, the acquisition of problem schemas improves problem-solving ability. Problem schemas describe the problem-solving process for a category of problems. So if you boil the problem-solving process down to its essentials, it consists of an initial problem state, which here is x minus 7 equals 12, of the operators, which are plus and minus, and of the operator's effect on problem states. Here, the effect of addition is that it brings the 7 to the other side of the equation and brings the problem closer to its solution. Worked examples are solved problems that are used as learning aids. The problem on this slide is a worked example. The magic word uses worked examples as a learning mechanism. Worked examples contain all the information that is needed to acquire problem schemas. Students use worked examples by going through them line by line and trying to understand how operators bring this problem from one problem state to the next. Here you can see a worked example from the magic word. Listeners will have noticed that problems that students solve themselves through active problem solving must contain the same information as problem schemas and worked examples. So why should we provide students with worked examples when they can attain the same information by just solving the problem themselves? In a nutshell, this is because active problem solving does not support the retention of this information as well as worked examples do. During active problem solving, attention is diverted from the information contained in the problem. It has been shown that problem schema acquisition is a separate process from the problem solving process. For this reason, the problem solving process takes cognitive resources away from the process of schema acquisition. This causes reduced integration of problem schemas into long-term memory. It also causes more attention to be directed at unimportant information. So the large amount of cognitive resources that are occupied by active problem solving are especially likely to stop beginners from acquiring problem schemas. This is because beginners require more cognitive resources to mentally represent problems in the first place. This brings us to the worked example effect. When studying worked examples, all cognitive resources are directed at the information that is needed for schema acquisition. Consequently, this information is processed more deeply than it would be during active problem solving. This is why worked examples are more suited to improving the problem-solving abilities of beginners than active problem-solving itself. In computer science, this also makes worked examples especially useful for female students. Female students may be experiencing stereotype threat. Stereotype threat reduces the working memory capacity of social groups that are stereotypically thought to have low abilities in a domain. Because worked examples put a low strain on the cognitive resources of a person, they should enable students experiencing stereotype threat to acquire problem schemas despite this obstacle. The problem with worked examples is that the study of worked examples is demotivating because there are no goals to reach. It is a passive process. This is why game environments can add so much value to worked examples as an instructional method. Game environments can counteract the negative motivational effect of worked examples by creating goals within the game. This is why we constructed the magic word around sub-goals that lead to an overarching goal. The game story is that a cat turns up in a girl's room and tells her that her dog is lost in a magical other world, and that the girl can control magic in this world. On their quest to save the dog, every spell the girl uses is a piece of code. The book of spells is filled with worked examples of code, and every time the user solves a coding problem, this brings the protagonist closer to her lost dog. The game's focus is on narrative and its characters. This, and the sub-goals and the sense of progress created by the individual challenges, gives the user a sense of immersion in the game world. In our study, we examined how worked examples improve coding ability in programming novices. We tested students who had not coded before. We compared the learning outcomes achieved by students in the worked example condition to that achieved by students in a control condition. This comparison was used to test the effectiveness of worked examples as a learning mechanism. Our hypothesis was that students will show more schema acquisition in the experimental condition than in the control condition. We tested 42 7th grade students with an average age of 13.8. The experimental group studied worked examples, which were followed by active problem solving. The control group studied instructional texts that were also followed by active problem solving. To measure problem-solving ability, we counted the number of correct code blocks written by participants and measured the time taken to write these code blocks. After this, 2 tests were conducted. One was used to compare the time between groups, and one was used to compare the number of correct code blocks between groups. These t-tests showed that the difference in the number of correct code blocks was not statistically significant. However, the difference in time between the worked example group and the control group was statistically significant. There was even a medium-size effect. This suggests that there was a higher learning outcome in the worked example group. The group was able to solve the same question with equal accuracy in less time. In addition to this, the students in the worked example group showed a more homogeneous ability level. This suggests that the worked example group's ability was caused by the experimental condition and not by chance. So we concluded that the learning mechanism of the magic word helps students acquire problem schemas. Worked examples are just one instance of an effective learning aid brought to teaching through cognitive psychology. Like other such learning aids, worked examples could only be used in a limited way before the advent of serious games. On their own, they are too demotivating for prolonged use. The ability to use learning aids like worked examples over longer time periods, due to the positive motivational effects of game environments, could help students make leaps in ability that would be difficult to achieve through other methods. Learning aids with cognitive and neural mechanisms at their core can improve learners' ability by strengthening specific neural pathways, or, as is the case in the magic word, they can mitigate the effects of the physical limitations of learners' working memory. I think that the transfer of methods from educational neuroscience and cognitive psychology into mainstream education through serious games is amazing. It's like the science fiction idea of using computers to alter the brain to achieve learning. The learning mechanisms provided by these fields create a much more direct route to the brain than the educational methods that preceded them. On this hopeful note, we would like to make a new version of the magic word with a more difficult worked examples and a more immersive game world. We would test this new version for flow, for the game's effect on intrinsic motivation, and for the cognitive load imposed by the learning mechanism. If one of you is interested in collaborating in producing and testing this prototype, it would be great if you messaged me. Thank you for your attention.